Now let's look at what happens if we have a capacitive load or a capacitive sensor like this. And the equation now becomes a function of impedance instead of resistance. So now we use Z instead. And this is the basic equation when the system is, the elements are numbered like on the drawing here. Again, we can divide every element here, every element in this first fraction here with Z3. Then we get instead 1 plus Z4 over Z3. And the other fraction here, divide everything by Z2 to get this here. Now, what I can do is that the part here, they are basically resistors. So they are basically the same as on the previous film. However, the impedance of a capacitor is J over omega C with a minus sign. And so it's minus J over omega C4. And this is minus J over omega C3. Omega is the frequency. J is the imaginary symbol for electrical circuits. Otherwise in mathematics you use I, but we use J. Now the J here is eliminated in that J there. Omega there eliminates the omega there. The minus sign eliminates the minus sign here. So we get C3 over C4. So this is the end result equation, resulting equation. Now, if C3 is our sensor, we see that V out is a function of C3. Voltage, a function of a change in a capacitor. When we try to make circuits like this, the frequency omega may be quite difficult to find, to adjust accurately. But fortunately for us, the omega is eliminated from this equation. So the output is independent of the frequency. However, you usually use a frequency so that there is some kind of balance in the bridge. So the overall impedance on the right hand side should be roughly the same as the impedance of the left hand side. Roughly the same, but not necessarily totally equal. But in order to get some kind of balance in the bridge, make them about the same size. And then you will have an equation that is independent of the frequency and which makes us able to calculate the voltage as a function of the change in the sensor capacitance. Same thing with inductors. One of the inductors may be a sensor, and the equation again manipulated just like I did before. The only change is that the impedance is now, for a capacitor, the impedance of a capacitor is minus J over omega C, while for an inductor is plus J omega L. So now it becomes J omega L over J omega L3. Remember that L3 is our sensor. J omega eliminates J omega, and we are left with this. And same here, V out is a function of L3. So V out is a function of our sensor L3. Again, we want to use the left hand side and right hand side somewhat similar in impedance, but not necessarily exactly the same, in order to get some sort of balance in the circuit.